Today, we're going to look at solving triangles. That's the first game that we're going to learn how to play, the solving triangles game. Now, a triangle consists of three sides, which are going to be three lengths, inches, centimeters, feet, and so on, and three angles, which will be measured in degrees. Degrees we're familiar with. We know that going all the way around a full circle, that's going to be 360 degrees. The way that the solving triangle game is played I give you three pieces of information, you find the other three. Given three, find three. The way we're going to play the solving triangle game. I give you three pieces of information about a triangle, and you find the other three pieces of information about that triangle. We're going to start the solving triangle game with right triangles. We're going to start the solving triangle game with right triangles. What that means is that one of the pieces of information is that one of the angles of the triangle is a right angle. This is what the triangles will look like and how we will name the parts. We're going to play the solving right triangles game. I've got to give you three pieces of information about a triangle. One of the pieces of information is that one of the angles is a right angle. This allows us to use certain words. We can call the side opposite the right angle the hypotenuse. We're going to set up some standard letters for our right triangle. The hypotenuse is going to get the letter C. The legs of the right triangle are going to get the letters A and B. Either one can be the vertical leg. Those are interchangeable, but C is the hypotenuse. I want to come up with names for the angles. I'm going to call the angle opposite A, angle alpha. So angle alpha is going to be the angle opposite side A. A and alpha go together. The angle opposite side B will be angle beta. So to make an alpha, you just make this little fish. Lowercase beta, it's like a B with extra long tail, and make it kind of round. The right angle is just going to be the right angle. On Tuesday, y'all explained to me some stuff that you already know about this triangle. You know that the sum of the angles in any triangle is 180 degrees. The sum of the angles in any triangle is 180 degrees. That means if I take angle alpha plus angle beta plus 90 degrees, we get 180 degrees. What that means in terms here, in these terms, is alpha plus beta plus 90 degrees is 180 degrees. If I subtract 90 from both sides of this, I see that alpha and beta have a sum of 90 degrees. Because we're dealing with a right triangle. The word for a pair of angles whose sum is 90 degrees is complementary. So alpha and beta are complementary. If alpha and beta are the two angles in a right triangle, then alpha and beta are complementary. This is a piece of information that exclusively deals with the angles in the triangle. Another piece of information y'all explained that you know is the Pythagorean theorem. Which says a squared plus b squared is equal to c squared using the abbreviations. The angle piece of information is for any triangle. The Pythagorean theorem is only for right triangles. That's okay. Later on, we're going to learn a better version of the Pythagorean theorem called the law of cosines. And that will work for any triangle. For right now, we're going to start getting the right triangles. That allows us to use the Pythagorean theorem. So I have a piece of information that only deals with the angles. I got a piece of information that only deals with the side. I need some kind of function that connects angles and sides of my right triangle. So we have something about the angles. We got something about the sides. Now we need something, some tools that connect angles and sides. Now we need some tools that will relate sides and angles. If I have two sides of a right triangle, I could find the third side with the Pythagorean theorem. If I know one of the angles of the right triangle, I can subtract from 90 with the other angle. But we need something that connects the sides and the angles. And for that, we have trigonometric functions. Trigonometric functions are going to give us relationships between angles and sides in a right triangle. So if I have an angle, I'm going to go a triangle. We're going to go a little bit more general here. I got a right triangle, so that means I have a hypotenuse and a right angle. I'm going to name this bottom angle theta, and we're going to define our trig functions. So the angle is going to be theta. That's going to be one of the angles of our right triangle. And then we're going to assign names to the other two sides. there's going to be a side opposite theta and a side adjacent to theta. So here's the side opposite theta. And the bottom side is adjacent to theta. I spelled A wrong. So the three sides of our triangle relative to one of the angles are going to be opposite, adjacent, and hypotenuse. Now we can define our trig functions. The sine of theta. Anyone know this one already? The sine of theta is opposite over hypotenuse. When you see this symbol, we abbreviate sine as S-I-N. The full word is S-I-N-E. This is sine of theta. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. I want to make sure we spell everything out. So we know when we see the symbol tan, then a theta, we read that as tangent of theta. When we see cos theta, we don't just say cos theta, we don't just spell out what we see. We read that as cosine of theta and sine of theta. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. You don't have to memorize these three definitions. You just have to remember these three definitions. Starting now and going on until forever. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. There are various mnemonic devices that go along with this. One that I learned was just the first letter of each ratio and remembering that we go in the order sine, cosine, tangent, and we say, oh, heck, another hour of algebra. So that's, just remember sine is oh, heck, opposite over hypotenuse. Cosine is another hour, adjacent over hypotenuse. And tangent is opposite over adjacent to OA. Another one that some people use is SOHCAHTOA, which I do not like. You could think SOHCAHTOA all you want, but you ain't gonna say it in my presence, unless you want to lose 1,000,000 points. But it's just SOHCAHTOA. SOHCAHTOA. I don't know what the water is like. I will just SOHCAHTOA. Here's the mnemonic device I use to remember these ratios. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So you might want to choose that one. No. I'm annoyed by even having written this down. I think it's because of the way that I was introduced to the mnemonic SOHCAHTOA. It was a long time ago, and I won't even repeat it in class. So, okay. wasn't really traumatizing so much as it was like super obviously racist to the point where I was a high school kid in the fucking 80s. I'm like, oh, dude, that's like not okay. But the teacher thought it was really funny. So you can guess how old the teacher was. He's dead now. I know that's cold, but I mean, that's all of our fates. So, especially when it's like Sokotoa. It's like, just imagine yourself dipping a toe in some water and just holding it there. It's like right there. That's why it was so offensive to me, because that one was right there and it's nice and neutral. You just like imagine yourself dipping a toe into a pool. It's right there. That's just what you're saying. And then this instructor was like, well, but what if we do a racism on it? Anyway, can we find out? So you don't have to memorize these. You do have to remember them. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And is opposite over hypotenuse. What we're going to do is we're going to see, and what we're going to notice is that each of these has three things: the angle theta and two of opposite adjacent hypotenuse. So it's setting up a relationship between three objects: the angle and two of the sides. That means if I have two of the side, one of the sides and an angle, I can use that to figure out the third side or another side. If I have two sides, I can use that information to figure out an angle. I can use this relationship to figure out an angle or to figure out one of the sides of the angle. And that's what we wanted to do. I need some way to connect the angles to the sides. And so here's how it's going to work. Any questions? Comments? Deep thoughts? Let's solve a triangle. Let's suppose so I need to give you three pieces of information. One piece of information. It's going to be a right triangle. And I'm going to tell you that the angle alpha is 57 degrees. And side C is equal to 15. I had to come up with a number and I got stumped. I had an uncountable infinity of choices. And I was like, I'll pick a number. Like, whoa, what do you want out of this number? I said, I just need a number. Well, how many digits? I don't care. 2, 3, 2, no, 3, no, 2, no, 3. And then I was in a loop. Let's go with 15 centimeters. There, I've given you three pieces of information. It's a right triangle. One of the angles is 90 degrees. Angle alpha is 57 degrees. And side C, the hypotenuse, is 15 centimeters. We can draw a picture if we like. I know that side C is equal to 15 centimeters. I think I put alpha down here, and so that's going to be 57 degrees. And there are my three pieces of information that we've been given. Now I want to make sure I label all the other things, because now I got to find the other three. So I've got to find this angle beta up here. I'm going to want to find side A, which will be opposite angle alpha. And we're going to want to find side B, which will be opposite angle beta. Then we're going to notice that I didn't bring that calculator, so I'm going to have to bring this calculator. So we got our calculators at the ready. What we're going to do is take the given information and use it to find out the other three things that we're missing. Here's the first thing we want to do. Always go after the easiest thing to find that uses the most given information. And the easiest thing to find, since we have two angles, the first thing we should do is subtract to find the third angle. If you have two angles, subtract to find the third angle. So if you know two angles, as soon as you have two of the angles, you should subtract to find the third angle. That's just good practice. So first we're going to find beta. And so beta, we know that the angles, the non-right angles in a right triangle are complementary. So I'm just going to do 90 minus 57. And come up with 40 negative 3. How much is that? What's 90 minus 57? No, you have a calculator. And we've got one of the pieces of information already. We now have an abundance of information. If you're thinking, God, it seems a little bit excessive to bring a calculator into 90 minus 57. That's because I skipped a thing in my mind and I couldn't get over it. Because the way I would subtract, I'd be 90 minus 50 is 40, and then minus 7. But I did it and I said negative to say the negative 7, but then I said 3 because I jumped the gun. And I said, wait a second, that's not right. 40 negative 7 is 30 and positive 3. So we now have 4 pieces of information about the triangle. We've got all the angles, we've got the hypotenuse. Now we need to go after the sides A and B. Doesn't matter which one we go after first, but I always like to use the most given information. So I'm going to use the 57, the angle, and C is 15, the hypotenuse. I notice that side A is opposite angle alpha, so I'm going to use sine. So A, side A, is opposite 57 degrees. And we know hypotenuse. So the trig function that we're going to use involves opposite of the hypotenuse, and that one is sine. Sine of theta is opposite over hypotenuse. So sine of 57 degrees is opposite over hypotenuse. Now I've filled out 2 of the 3 pieces of information. I can just do some calculations to find out the missing piece. Notice that this says sine of 57 degrees is A divided by 15. So to figure out what A is, I can just multiply both sides by 15. So I'm going to say A is 15 times the sine of 57 degrees. I'm not going to bother figuring out the sine of 57 before I need it. And I didn't need it yet. Now I see that A is 15 sine of 57. So I'll just grab my calculating machine and I'll say, hey, calculator, what is 15 times the sine of 57? To do that on this calculator, I have to go a little bit backwards. The sine button on this calculator takes the sine of what is ever on the screen. So I can't type it like I see it. And I have to say equals. So once again, I have 15 times the sine of 57. I can't type it on this calculator like I see it. I have to put in the 57 and then ask for the sine. And I'm like, oh, yeah. Multiply 15 by that. You could also just lead with the sine of 57 by going 57 sine and then multiplying by 15. The way that you have to remember is that on your phone calculator, the sine button just takes the sine of whatever's on the screen. It's like, okay. Good. Until it runs out of stuff. So, and now I erase it. 12.58. Let's call it 12. In this case, I rounded my answer off to the nearest 10. This is usually where I ask you to round your answers. I didn't ask for that. Because I figured I'd just tell you that and then write it all down. So the thing you want to note is that we rounded to the nearest 10. So we're going to make a note of the fact that the 12.6 has been rounded to the nearest 10th. But now I've got 5 pieces of information. Now we might also notice that side B is adjacent to the 57 degrees. So note that side B is adjacent to 57 degrees. And we know the hypotenuse. So I can do the same thing for side B that I did for side A, using the hypotenuse. But this time I need adjacent on hypotenuse, and that tells me to use cosine. So I'm going to say that the cosine of 57 is adjacent over hypotenuse. So cosine of 57 is B over 15. Since the cosine of 57 is B over 15, B is equal to 15 times the cosine of 57. Or 8.2, it's not in the nearest 10. And this has also been rounded to the nearest 10. Any questions? Once we have an abundance of information, we're going to have choices as to what to find next. So that's great. We'll be able to choose what we want to find next. But this is also terrible because now we have to choose what we're going to find next. We all think we want choices until we have to make a choice. And we go, oh, what if I make the wrong choice? You can't make the wrong choice. You just got to pick one and go. So notice that at the time we found side B, or the strategy that I used to find side B, I said I have an adjacent side and the hypotenuse and the 57 degrees. So I use that. The reason that I picked switching to cosine rather than using the side A that I found at 12.6 is that 12.6 has been rounded off. So it's not exactly 12.6. It was 12.58, and there were some more digits. I want to use as little rounded information as possible. Also, I could use the 12.6 and the 15 in the Pythagorean theorem to get at side B. But using the 12.6 is riskier because the 12.6 has been rounded. So note. So we're going to work this way. So we could have also used the 12.6 and the 15 in the Pythagorean theorem at this point. That would look like 12.6 squared plus b squared, the one we're looking for, is equal to 15 squared. So b is going to be the square root of 15 squared minus 12.6 squared. So I'll just grab 15 squared minus 12.6 squared, and then the square root of that. And we get 8.1. When we round to the nearest 10. Notice that this is different than the 8.2 that we had before. And the reason is we rounded off to 12.6. So it's not exactly the 8.2 because the 12.6 has been rounded. We didn't get the 8.2 we got before because the 12 points. What's that? Yes, because it's not, this is a calculation that's based on rounded information. That rounding error led, that rounding led to the error. So the 8.1 would be rounding. Now, the reason was that I specifically stopped at 12.6. If you recall, that 12.6 came from a 12.58. And that'll change things a little bit. If I do 15 squared minus 12.58 squared, and then take the square root. It's 8.16. And if we rounded that to the nearest 10th, we'd be at the same 8.2. And so I wouldn't be able to know if there was any rounding error. But if the 12.6, that's been rounded too much to use in further calculations if we're going to be rounding our answers to the nearest 10. Any questions? Note that we will get the same 8.2. So let's see, 57 cosine times 15. So that was going to be 8.1695855. And at this point, the calculator on your phone is just showing off. It's like, oh, look how many digits I have. And you're like, oh, calculator, that's a weird flex because no one needs those digits down there. Oh, but you have them. It's like, oh, I kind of don't want them. Take the digits. So let's remember that number. that 12.6 was the sine of 57 times 15. If I use this entire number in all of its excess, then I'm going to get the same 8.1. So if I square this, change the sign and add 15 squared, and then take the square root, notice that this, all the way down to the 406 at the end, is the same. It's the same 8.2 that we got before, because I did not round off all the way to 12.6. Here's how things are going to be scored on Canvas, and you are not going to like it. And I won't change it. I set up a problem like this. The answer to this is 8.2. 8.1 will come back wrong. You're like, oh, it's only off by a 10. Hey, boss, it says $8.1 per hour, and it's supposed to be 8.2. It's only off by a 10. So it's going to matter. I set it up this way deliberately. So it's only going to get an 8.2. Because that's what you can get if you don't use rounded information, or if you don't round off before you get to an answer. So 8.1, it'll be like, oh, no, wrong. And they go, fine, dick. And then you just go back and do the 8.2. Yeah, a leak is so petty. You can write bad things about me on late night. I've been threatening to go and tank my own score on late night professor, just because I can. It's like make up a bunch of bad things about myself. I don't know if it still exists, but if you've been to ratemyprofessor.com, you really need to go to Professors Strike Back. These are responses by professors to their reviews on ratemyprofessor.com. They're video responses. So it's amazing. No, I haven't. I don't know. I just got other things to do. What I wanted to do was go on to ratemyprofessor.com and write escalating bad reviews of myself that get more violent as they go along. It's like, well, he yelled at me just because I didn't round to the right 8.1 instead of 8.2. It's like, oh my God, he threw the book at me when I got the wrong answer. It's like, well, he threw me out of class. And it's like, oh no, literally, he grabbed me and threw me out the door. What's wrong with this guy? And then I'll film a video response where I'm just acting like a crazy person. It's like, oh, that's right, if you show up in my class, you had better be ready to be right. As if you were wrong. If you were wrong. Yeah. Like in like on the wall, there's like pens that are like, not even with the cap off. It's just like a dry erase marker halfway into the wall. There's nothing I hate more than wrong answers. Ah! And I throw it, and then like you hear this big crash, and then the camera like pans over, and it's just this thing of destruction. And then when the camera comes back to me, I'm going to be running at the camera. It's like, well, now turn it off right now. I think I haven't done that though, because I don't think I have time for performance art. I'm too busy. That's what I wanted to do. I've been threatening to do that for a long time. I don't even know if Professor Strike Back still exists. But someone report back on that. That's part of your homework. All right. Normally at this point we would be stopping for a few minutes, but I only have one more thing to do. We learned how to find sides. What we need to be able to do is be able to find an angle. So the book doesn't think that you can handle this until way later. But I say the book is wrong. You can totally do this. So here's how we're going to use trig functions to solve for an angle. So here we are using trig functions to find an angle. Specifically, we're going to need to use inverse trig functions. And check the table of contents. Inverse trig functions is not so very limited. We don't keep secrets around here. I don't care what the council says. We're getting information. So let's suppose a right triangle. And I'm going to tell you two of the sides instead of one of the angles. C is going to be the hypotenuse. That'll still be 15 degrees. Let's make one of the sides not the values that we had before, which were 12.6 and 8.1. And let's suppose that side A let's suppose that side A is 10.7 centimeters. You can tell this is much more serious problem because I'm using investment in my length. Not just going full integers. They're starting off in the nearest 10. We can draw a picture if we like. In case you're wondering, my drawings are never to scale. It's always this same triangle. So those are the three pieces of information we have. We've got the hypotenuse, side A, and the right angle. The right angle counts as well. So we got the things that we need to find are angle alpha, that's going to be opposite side A. We need to find angle beta. And we'll also need to find side B. Have 3, want 3. One of the things that we have is a hypotenuse at 15 and A at 10.7. So we can use this to find alpha by noting that A is opposite angle alpha and C is the hypotenuse. So A is 10.7 is opposite alpha and hypotenuse is 15. Since I have opposite and hypotenuse, that tells me that I want to use sine. Sine is the trig function that involves opposite and hypotenuse. So I will say that the sine of alpha is opposite 10.7 divided by hypotenuse 15. So now I'm looking for an angle, and I know the sine of the angle is 10.7 over 15. So to figure out what the angle is, I'm going to have to use the inverse sine. I'm going to have to use the inverse function. So let's do that on our really expensive calculators. So first, let's talk about how to write this. If the sine of alpha is 10.7 over 15, then alpha is going to be the sine inverse of 10.7 over 15. That's how we're going to write it. If you have a TI-84 calculator, this is how you're going to type it as well. Exactly like this. You're going to press second sine to get the sine inverse function. Then you're going to put parentheses. Actually, I think the 84 put parentheses for you. And you just do 10.7 divided by 15.0. So if you've got the TI-84, you will just press second and then the sign button. Because when you press second sign, that brings up the sign inverse above it. That's the buttons for that command. Now, on my phone calculator, I can't just type it like this. The sign inverse button takes the sign inverse of whatever is on the screen at the time because primitive. So I have to do the 10.7 divided by 15 first. And then I want the sign inverse of this. So I press second, and then notice it changes the buttons to sign inverse. That tells me that it's a 45.5 degree angle. Any questions? Yes. Yeah, you would press second, sign. Yeah, close parentheses and then enter. And you can do that. Now, if it doesn't, if it's giving you something weird, make sure your calculator is in the right mode. So this button down here will switch me to radian mode. So now my calculator is going to be speaking in the language of radians. We haven't talked about radians. So you don't want your calculator to be like all rad. So turn it back into deg, or just turn that part off. On the TI-84, you might have to do this in the menu. So there's going to be a button where you bring up the menu. And one of the things is to switch from radians to degrees. For this first chapter, you can just put your calculator in degrees and leave it in degrees. And then we'll know to switch. Later on, we're going to have to switch over to radians. But like it says right here, it'll be rad. Any questions? At this point, we have an abundance of information. In particular, I have two angles, so I should subtract to find the third. As soon as we have two angles, subtract to find the third. Then we have an abundance of information to go after the third side, B. In this case, it might be best to find B with the Pythagorean theorem because A and C have not been rounded off. Those are not rounded off. Those are given information. Those are both given. And using that 45.5 degrees is a little bit suspect now because that 45.5 has been rounded off. Any questions? All right. We can use these trig ratios to get it aside, or we can use the inverse trig functions to find angles. To do that, we press second sign to get the sign inverse key. On both calculators, it says second and sign. Does anybody have an Android phone? Is it second or is it shift? Okay. They all have to be different. Oh, yes. That's actually a little bit better, but it takes up more space. Yeah. So it might, the other name for sine inverse is arc sine. The reason is that the abbreviation sine with the -1, it looks like an exponent, and we don't want to think of this as sine to the -1. We want to read that as sine inverse. If you want to say sine to the -1, you have to say something else because math. Any questions? Yeah. Yeah, we could do a cosine to solve for b because it's adjacent to the alpha. If you're going to be using cosine, then you have to be grabbing an angle that's adjacent. So b is adjacent to alpha. So if you want to use cosine to find b, you're going to have to use the angle that's adjacent. If we had angle beta, we could say side b is opposite angle beta, in which case we could use sine again. Yeah, side b will always be opposite angle beta, just to keep it simple. We'll always use the same setup. Any questions? So a lot of times, like I said before, a lot of times you have a choice in what you try to find first. So that's good, you have options, but that's also bad, you have options, because now you have to choose which thing you're going to go for first. In general, I say as soon as you have two angles, subtract to find the third, because that's the easiest operation. And if we're thinking of playing the game, as I'm going to have you find three things, if you can get one from just subtraction, then you got to do that first. Number 2 rule, you can use whatever you want to solve, but be careful with the rounded off information. Don't round off until the very end. Don't use 12.6 when you know that's been rounded off. Use 12.58, or if you're not sure, 12.5800. Use some more decimal places. Any other questions? Comment? Yes. Yes. Yeah. So the 45.5, and then you'll also get a 44.5 for the other angle, because apparently I just divided by the square root of 2. But the other angle is 44.5. Those have both been rounded off. So I would just use the whole angle. Oh, I erased it on my calculator already. I would just 10.7 divided by 15 second side. Just use more digits if you're not sure. Any other questions? Yes. So when you said the it depends. Yeah, it depends on what I say. It'll always specify. So I think the ones that are up on Canvas right now say round your answer to the nearest 10th of a degree. So you'd want to say 45.5. If I had said round to the nearest 1,000th of a degree, the first thing you should think is, why do you have to take it so far? Do you realize how small of a piece of a change that is? Well, because I wanted 5 significant figures. Well, I'll just specify where you want to round it. Round to the nearest 10th of a degree, and stop there. Any other questions? That's everybody okay? I just mentioned that there are 2 quizzes that are up on Canvas. At the top, one of the modules is called quizzes. The quizzes showed up yesterday, and they are due next week on Thursday. It's just a couple of solving right triangles. Some of the homework problems are going to be word problems. The word problems have a right triangle in them somewhere. At this point in your trigonometric career, all word problems have a right triangle. Just look for the right triangle and then start naming the pieces. There's nothing fancy about it. You don't have to understand anything about airplanes coming into land. You just have to find the triangle in the problem. All right. That's going to do it for today. I will see you all on Tuesday. Everybody have a good day. Everybody have a good weekend. And thanks for playing.